This is a GAIN data landing page where you can access Interrogator to explore datasets on Alzheimer's disease, related dementias, and aging. You can create an account via the instant free sign-up link, and after logging in, you will see this Interrogator workspace. In the Interrogator, data partners are grouped into longitudinal and cross-sectional datasets. You can filter datasets that contain your data categories of interest, as well as sort by name, country, number of subjects, number of variables, and last updated dates. You can go into any data partner to explore the variables they have shared with GAIN. You can also create your own cohorts of subjects based on any variable. For example, we can create an MCI cohort and a dementia cohort based on the impairment level variable. You can then use these cohorts to set up a preliminary analysis, for example, linear regression. For linear regression, you would need one cohort and two numerical variables per analysis. For example, we can look at the distribution of MMSE scores, as well as centiloid values, which is a quantifiable measure of brain amyloid. In the linear regression tab, click and drag your first cohort and your independent and dependent variables. In this case, the independent variable is centiloids and the dependent variable is MMSE score. Add another analysis to compare the regressions between different cohorts. So click and drag the second cohort and the MMSE and centiloid variables. Name each analysis according to the cohort. And then you can click on Run Analysis. Right away, you'll see the results, which show a negative association between centiloids and MMSE scores in both MCI and dementia cohorts, with the dementia slope starting at a lower y-intercept. This indicates that higher brain amyloid load is associated with worse cognitive scores. These results are for your reference only and not for publication because the preliminary analysis does not adjust for confounding variables and detailed methods are hidden. To conduct an analysis for publication, you would need to request full data access via the Apply link below the study logo on the GAIN data landing page. Back in the Interrogator, you can also pull multiple data sets for a meta-analysis. For this example, we are going to reconstruct an analysis from one of our recently published manuscripts, where we compare brain amyloid load as reported in the centiloid scale between Hispanic and non-Hispanic white cohorts. You can find the full manuscript following this QR code or DOI link. In Table 6 of this manuscript, we conducted a binary logistic regression with centiloid values greater than or equal to 10 as the outcome for amyloid pathology to compare the influence of the APOE E4 allele on amyloid pathology between Hispanic and non-Hispanic white cohorts. This analysis included data from 4 GAIN data partners and adjusted for age, sex, education, and cognitive diagnosis. In the Interrogator, we would need to find data partners with neuroimaging and genetic data types so we can apply those filters. Here, neuroimaging data includes amyloid PET, tau PET, and MRI measurements, so we can specify centiloid in the search field on the top right. We are left with 6 datasets, and we will pull BACS, NAC, and ADNI for this demonstration. Data from NAC and ADNI were used in the manuscript, and BACS is newly available. So this is a good example of validating results with slightly different data sources. Click on Pool Datasets, select these 3, and name this pooled dataset. Now this interface is similar to that of a single dataset, except the variables are now grouped by data partner. To conduct a meta-analysis, we would need to map individual variables to a pooled variable. For example, using the centiloid variable from BACS, click on Map to a pooled variable, then select Map to 0 or 1 and set values above a certain threshold to 1. You can adjust this threshold with a slider or type in a specific value. Following the manuscript, we can type in 9.5 to include centroid values 10 and higher as 1. Click on Create and name this variable. You can include the cutoff you used in the name of the variable. Now we can finish mapping the pooled CL greater than or equal to 10 variable with the other data partners. You can search for centroid across all data partners, and this time click on CL greater than or equal to 10 from My Map Variables. Make sure you choose the same range division as before, and then repeat the same process for the last data partner. Now we need a pooled APOE E4 variable. Search for APOE and click on Map to a new binary variable. This time, set any genotype with an E4 allele as 1, so that is E2E4, E3E4, and E4E4. And make sure those with missing genotypes are excluded. Click on Create and name this APOE E4. Repeat this process for the other two data partners. Now we need to create some race and ethnicity variables from which we can later define our cohorts. First, create a pooled ethnicity variable where Hispanic or Latino is defined as 1. Repeat with the other data partners and make sure to exclude those with unknown ethnicity. Now we will create a race variable. I'm typing in RAC in the search bar so that I can find variables that are called race or racial category. You can choose My Values to create a categorical variable with your own labels. We can shorten the labels here and click on Create. For the other data partners mapped to the same race variable, you'll notice that the labels must be typed exactly the same way for the subjects to be grouped into the same categories as the first data partner. Click on Done and repeat for the last data partner, and be sure to exclude the unknowns. Now we will create 4 cohorts based on centroid values and race and ethnicity. First, let's create a non-Hispanic white cohort with centroid values less than 10. Select 0 for CL greater than or equal to 10. Name this cohort. And with this cohort still selected, go to the ethnicity variable, select 0, and click on Add Condition. And now go to the race variable, select white, and then Add Condition. Finally, go to the age variable, and let's exclude the younger controls that some of these studies recruited. In the manuscript, we included participants aged 55 or higher, so we can do the same in the interrogator by selecting ranges 2 and 3 and setting the cutoff to be 54.5. Click on Add Condition and close out of this cohort. We can repeat these steps to set up a non-Hispanic white cohort with centiloids greater than or equal to 10. Select 1 for the CL greater than or equal to 10 variable, and follow the same steps to add the race, ethnicity, and age conditions. Now repeat the same steps for the Hispanic cohorts. Just select 1 for Hispanic, and you don't need to specify race here. Now we're ready to set up our analysis. In the Analyze tab, make sure Logistic Regression is selected. For logistic regression, you would need 1 control cohort, 1 case or outcome cohort, and at least 1 independent variable. So our control cohort is centiloids less than 10, our case cohort is centiloids greater than or equal to 10, and the independent variable is a binary APOE E4 variable. Click on Add Logistic Analysis to set up the Hispanic analysis in the same way. Name each analysis for the legend and click on Run Analysis. For logistic regression, you get odds ratios as results. As you can see, APOE E4 is associated with centiloids greater than or equal to 10 in both non-Hispanic white and Hispanic cohorts. But the odds ratio for the non-Hispanic white cohort is significantly higher than the odds ratio for the Hispanic cohort, as seen by the non-overlapping confidence intervals. We can now compare this with the results from the manuscript. The odds ratio is lower in the manuscript for the non-Hispanic white cohort and about the same for the Hispanic cohort. Remember that the published analysis included covariates and used a different combination of data sets. The published results and the preliminary results do trend in the same direction, which is a good way of validating results using different data sets. Back in the interrogator, you can save your pooled dataset by clicking on the Save icon on the left. This preserves your pooled variables and cohorts. To save how the analysis was set up as well, click on the Save icon next to the Run Analysis button. You can find your saved datasets under My Pooled Datasets and saved analyses under Analyses. If you don't save, the pooled variables and cohorts will be cleared next time you log in. If you need additional assistance for your specific research question, feel free to reach out to info@gain.org.